Hello dear students, today we shall study one more interesting lesson, that is light. In our day-to-day life activities we come across so many phenomena which are related with light, such as colorful rainbow, twinkling of stars, it may be bending of light by a medium or image formation by mirrors. All these phenomena we see. Not only this, we have been using so many optical instruments in our day-to-day life activities. For example, microscope, it may be telescope, binoculars, kaleidoscope, periscope or spectroscope. All these instruments, they are working mainly based on the principle of light. Then coming to the principle of light, we need to study the light into depth. What is that? The light acts as wave and it acts as ray. In this lesson we are going to deal with only the ray property of light. We are not taking wave nature, here only we are taking ray property. In this lesson, special we are going to deal with only two phenomena, that is reflection and refraction of light. Coming to the reflection, what is reflection of light then? First, let us understand the definition of reflection. Very simple. When you take a surface here, if this is a surface with dot lines, if we show this is rough surface, this is our polished surface. If light rays, if it fall on a polished surface, it will be bouncing back. This bouncing of light rays from a polished surface is called what? Reflection, as you already studied in the previous class. Now, coming to what is, there are two laws of reflection, that also we must understand first. What are those two laws? Coming to the laws of reflection, first one is what? If you take a surface, here this is rough one, this is polished surface. Here, this ray which is incident on this surface, that is called incident ray. This is incident ray, and this is after reflection, what it moves, that is called reflected ray. This is reflected ray, this is incident ray. Now we have to draw a vertical line perpendicular to this surface. This is called what? Normal. This is normal. Now the angle made by this incident ray with normal is called angle of incidence, and the angle made by this reflected ray with this normal, it is called what? Angle of reflection. Now the first law says what? The angle of incidence is equal to the angle of reflection. This is first law. What is second law then? Second law says what? The incident ray, the reflected ray and normal at the point of incidence all lie in the same plane. These are two laws which are what is called laws of reflection. What are these? Just first one is what? Angle of incidence is equal to angle of reflection. The second one is what? The incident ray, the reflected ray and normal at the point of incidence all lie in the same plane. Same plane means what? All can be drawn in the same board here. If one line is out of the board, then we cannot say they are in the same plane. So this is just a laws of reflection. Now let us come to know about a plane mirror. Coming to plane mirror, as you already studied, in a plane mirror, how are images formed? What will be the nature of image formed by a plane mirror? That we need to understand first. When we stand in front of a plane mirror, as we have already experienced, just we can see our image. When we are standing, it will be virtual and direct. The first point is what? It is virtual and direct. Virtual images means the images which can be seen within the mirror but not on a screen. They are called virtual images. If the image can be caught on a screen, means like projector, if we can get it on a screen, that is called real image. So in a plane mirror, we find our image within the mirror, that is called virtual image, and it is erect. Erect means as we are, it is looking same as it is. If it is turning upside down, that is called inverted image. Okay, so whatever object you take, for example, if you take here, this is erect, I am holding. In the image, in the mirror, if you see this one like this upside down, this is called inverted image. Okay, if the image is coming as it is, that is called erect image. So virtual and erect image we are getting in a plane mirror. Next, so what is the size of the image and object we need to consider? As we are standing in front of the plane mirror, our size and same size of the image can be seen there, right? So any object if you hold in front of the plane mirror, the size of the image is same as that of the size of the object, we can say. This is second property. Next, when we are standing in front of the mirror, just let us move 2 steps backward. What happens? Our image within the mirror, that also moves 2 steps backward, right? Means what? Here the distance of the object in front of the mirror, in a plane mirror, is equal to the distance of the image behind the mirror. For example, see here, if this is object and this is image, right? Here what distance is there, same distance it can be maintained here. Okay, if it is 1 meter, here also 1 meter, means what, image distance of the object from the mirror is same as that of the distance of the image from the mirror behind it. So here this is next one. Next we also see, what do we see, one more property here. In a plane mirror, if we lift our right hand, it looks like we are lifting our left hand, means what, lateral inversion takes place. In a plane mirror, images will have lateral inversion, means right appears left, left appears right. These are what, just properties of image formed by a plane mirror. Okay, this is just about a plane mirror. Now in this lesson we are going to deal with only the spherical mirrors. Then we need to understand what are spherical mirrors then. Coming to spherical mirrors, what are those? Let us take a spoon. If you take the spoon here, what happens? This surface curved inwards, we can see our face in that also, and this side also we can see, right? So here this surface of that reflecting surface of the spoon, since it is curved, that is what, spherical mirror. It is not spherical mirror, it can be approximated to spherical mirror. It is not a completely spherical, but it can be approximated to a spherical mirror. Then in this lesson especially we are going to deal with the spherical mirrors. What are spherical mirrors then? There are two types of spherical mirrors. One is concave mirror, the other is convex mirror. So let us take here, spherical mirrors means the mirrors whose reflecting surface is curved, they are called spherical mirrors. This curve, if you extend, if you continue, it forms a sphere. So how we are getting this reflecting surface? This is part of a sphere. Because of that, this is called what? A spherical mirror. Now you see, now what we got here, this is a mirror whose reflecting surface is what? Curved inwards, means it is curved inwards it is. So this is called what? If the reflecting surface is curved inwards, this is called what? Concave mirror. It is concave mirror. If you take another type of mirror whose reflecting surface is curved outwards, we can see our image on this surface, this side. So if you extend this and make it, this is also a sphere, means what, this reflecting surface, it is also part of a sphere. So this is called what? Convex mirror. If the reflecting surface of a mirror is curved outwards, that is called convex mirror. If the reflecting surface is curved inwards, that is called concave mirror. These are just two types of spherical mirrors that we are going to deal with in this lesson. Now coming to, we need to understand some of the terms which are related with these, what, convex and concave mirror, that we need to learn now. Just we understood what is concave mirror and convex mirror. Now let us study some of the terms which are related with convex and concave mirror. Always when we draw a mirror, just remember, when we draw a curved line, one side fairy will show this is what, rough surface, this is what, polished surface. Means what, here this is polished surface, in what, curved inwards it is. Here this polished surface is curved outwards. So this is convex mirror, this is concave mirror. Now coming to, which are the terms related to these spherical mirrors, that is concave mirror and convex mirror. First one, taking this concave mirror, if you extend this curved surface, we get a sphere, right? This sphere, it has one center, right? Now coming to here, this reflecting surface, if you take it, for example, if you take this reflecting surface like this, put a drop of water, if it comes and it stands at the center, right here, it comes to the center. This center of this reflecting surface, it is called what? A pole of the mirror. It is denoted by P. P means what? Pole. And this reflecting surface, if it is continued, it forms a sphere. This sphere has a center. This center is called what? Center of curvature. Okay, this is curvature. Its center is C here. This is called center of curvature. Now this over. Next coming to here. This reflecting surface from here to here. This has a diameter. Okay, this has a diameter. This is called what? Aperture. This is called aperture of the mirror or reflecting surface, we can say here. Means aperture of the spherical mirror is what? Nothing but it is the diameter from one end to the other end. This is aperture. Next coming to here, we have to also see here the distance between this is called what? Pole, means center of this reflecting surface, that is called pole. This is center of curvature. The distance between center of curvature and the pole, it is called what? It is, this distance is called what? Radius of curvature. This distance, it is called radius of curvature. We call it as radius of curvature and it is denoted by R. This is pole P. This is C, center of curvature C. Here, in case of convex mirror also, here, this is center point called pole P, and from here to here, when it is formed in the form of a sphere, this has a center. This center is called what? C, center of curvature, and the distance from pole to this is center of curvature. It is taken as radius of curvature. Now you can take here center of curvature. In case of convex mirror, it is behind the mirror. In case of concave mirror, the center of curvature is in front of the mirror. These points you have to remember. Now this is just over one few points. Next we have to learn few more terms which are related with these spherical mirrors. When image is formed, when rays of light are incident on that reflecting surface. Now you take here, let us take the same one. Here a line, an imaginary line passing through this center of curvature and pole. This is called what? Principal axis. We call this as principal axis. And here also in case of convex mirror, a line, an imaginary line passing through center of curvature and its pole P is called what? Principal axis. That principal axis. Now here, when light rays are incident on a concave mirror, they after reflection they meet at a point on the principal axis. This is called what? Principal focus. We call it as principal focus and it is denoted by F. Next, coming to this is F. In case of convex mirror, what happens when light rays are incident on that mirror? After they diverge, after reflection they diverge, and these rays after diverging they appear to be emerging from a point on the principal axis. This is called what? Principal focus. So we can also understand here principal focus, it lies behind the mirror in case of convex mirror, and in case of concave mirror again principal focus is in front of the mirror. We need to learn more, understand this. Next, coming to here distance between this principal focus and the pole of the mirror is called what? Focal length. It is also denoted by a letter called F. Okay, this is F. Then how do we know where is this principal focus? Then for this we need to do an activity through which we can understand to find the principal focus. For example, you take a concave mirror. Taking a concave mirror, you hold this concave mirror facing towards the sun and hold a sheet of paper here. After reflection, this from this the light, after reflection from this concave mirror, it forms a bright spot on the paper. Okay, when you move it back and forth, this concave mirror, it forms a bright spot here on the paper. It may catch fire and it starts burning after some time. So this bright small very much point size bright spot what we get here, that distance from this pole of the mirror, this is called what is focal length. This is how we can get the focal length. Okay, now what all we understood? We studied what is pole, center of this reflecting surface is called pole. Next, what is principal focus? After reflection, light rays, they what meet at a point on the principal axis, or they appear to be diverging from a point on the principal axis. That point is called what? Principal focus. Next, this reflecting surface, when it is continued as a sphere, it has one center. That sphere has one center. This is called center of curvature. Okay. This over. And now the distance between this center to the pole on the principal axis, or from the center to any point on the reflecting surface, it can be through the principal axis or anywhere. You take here line from center to any point on the reflecting surface, that is called a radius of curvature. This distance from center to any point on the reflecting surface. Here also from center to any point on the reflecting surface, here if you draw any line, that gives us what? Radius of curvature. That gives radius of curvature. So all these terms we learned. Now coming to, we have to learn representation of images formed by spherical mirrors using ray diagrams, that we need to learn. In order to draw the ray diagrams for images formed by a spherical mirror, we need to learn some rules are there. A set of rules are there that we need to learn first. When you take, what are those rules? First one, if you take a concave mirror, when you draw a mirror, you need to show the rough surface, the other side to the left, polished surface. Now this has a center point called pole P here, and this line which is passing through the center of curvature, okay, to the through the pole, this is called principal axis. Okay, now a ray which is parallel to the principal axis, after reflection it passes through the focus. Okay, this is principal focus. Now you see this point where it intersects with what? Principal axis. This point of intersection, that is called what? Principal focus. When it is parallel, it passes through focus. Okay, and in case of convex mirror, what happens? The same if you consider in case of convex mirror. This is principal axis. Now here this is pole P, and here F, here C, center of curvature. Now a ray which is parallel to the principal axis, after reflection it diverges, right? It diverges. But this divergence, how it appears? It appears to be diverging from a point on the principal axis, that is principal focus. This is first law. Okay, that is first rule. It is, we can say, if it is parallel it passes through the principal focus, or if it is parallel it appears to be diverging from the principal focus. Okay, this is first law, first rule. Second rule, what it says, see, if a ray of light, same, if it is parallel it is passing through focus, right? Now in second rule, what it says, if the ray of light, if it is already passing through the principal focus, this is center of curvature. Now you see, after reflection it emerges parallel to the principal axis. Okay, it emerges parallel to the principal axis. Here we need to show here one line which is passing through the center of curvature. Means what? This is nothing but normal at this point. Means what? Here angle of incidence will be equal to angle of reflection. To show that, we are drawing this. Next, coming to here if a ray is incident, if it is passing through the principal focus already, after reflection it emerges parallel to the principal axis. In case of convex mirror, what happens then? Let us take this. Here pole we need to show. Here in case of convex mirror, this is pole P. If a ray is appearing to be passing through principal focus. Now you can see here, I'll show. You have to show this with the dotted lines, okay, because behind the mirror to understand. Now after reflection, this emerges parallel to the principal axis. Okay, after reflection it emerges parallel to the principal axis. It is appearing to be passing through the focus. After reflection it emerges parallel to the principal axis. This is second one. Okay, now we can show here also, in case if you want to know, here the law of reflection will be followed. It passes through the center of curvature. One line we can show, means angle of incidence will be equal to angle of reflection we can show. Now coming to third rule. What does the third rule say then? In third rule, if a ray is passing through the center of curvature already, for example, this is concave mirror, right? Here this is principal focus. Let us take this is the center of curvature. If a ray of light is incident on this spherical mirror passing through the center of curvature, what happens after reflection? It follows the same path, means it does not change its direction. It follows the same path. In the same path it returns back. Okay, this is pole. Again coming to here, in case of convex mirror, what happens here? You have to show here, this is principal focus and this is center of curvature. Now a ray which is appearing to be passing through, see with the dotted lines we have to show this one, inside the mirror, means behind the mirror. It follows the same path after reflection. See, it is going in the same direction and coming in the same direction. This is third rule. Then what does the fourth rule say then? Fourth rule I'll draw here. Now fourth rule says, what it says? Here in a concave mirror, if a ray is incident obliquely, this is principal axis, okay, concave mirror, pole. Here also we'll draw convex mirror, principal axis, this is pole. If a ray is incident obliquely towards pole P, after reflection, it emerges obliquely here, this after reflection, and it follows the laws of reflection. That is what angle of incidence will be equal to angle of reflection, you can see here. And here in case of convex mirror also, if a ray is incident obliquely towards pole P, it emerges obliquely, okay, making what, following the law of reflection. Law of reflection means what? Angle of incidence will be equal to angle of reflection. This will be followed. In case of, this is in case of, this is pole P, okay. Let us show F and here C we can show, no problem. Here this is in case of convex, this is in case of concave mirror. So the laws of reflection will be followed. And here this is all just some set of rules that we need to remember in order to draw the ray diagrams, okay, for images formed by spherical mirrors. Next, let us come to know we have to learn now the image formation by spherical mirrors. What will be the position, nature and size of the images formed by spherical mirrors? First one, let us take here. We have to take first when the object is at infinity. When the object is at infinity, what will be the nature, size and position of the object that we need to learn. So let us take first, in this especially we are studying with separately how image formation by concave mirrors we study in first one, and in second case we study image formation by convex mirror. Especially we are dealing with only image formation by concave mirrors here. First, okay, concave mirrors, the position. Now what is the position of the object now? At infinity, when the object is at infinity, okay. when the object is at infinity, what happens? What will be the nature, size and position of the object? Let us try to know here. This is concave mirror, this is principal axis. Now we have to show this is principal focus, this is center of curvature. See, okay, now center of curvature. When the object is at infinity, the rays which are coming from that object, they will be parallel to the principal axis. They are considered as they are parallel to the principal axis. After reflection, we need to take here two rays for reference. Remember, two rays we are taking. After reflection, they pass through a point on the principal axis called principal focus. Okay, they are passing through the principal focus. After reflection, these are first parallel there. When the object is at infinity, the rays are parallel. After reflection, the rays, they meet at a point on the principal axis called principal focus. Now, what will be the nature? Here, point sized, what image we get? Image is what? First one, it is, we are getting real image. Image will be inverted and real. Always when we get real image from that concave mirror, it will be inverted, means upside down it looks. So image is real and inverted. This is what a nature it is. Second one, size. What is the size? Size is point sized. It is point sized or diminished, highly diminished. Point sized or highly diminished. Then where is the position of the image then? Image is formed at F or not here? So image is formed at F. Image is formed at F. At F means what? We find the image at principal focus. So this is first one. When the object is at infinity, the image is real and inverted. It is point sized or highly diminished, we say. Next, what do we say? Where is that found? It is found on the principal axis at a point called principal focus. At F, we find this image. This is first one, when the object is at infinity. Then what happens when the object is beyond C? Second case we have to study, that is beyond C. When the object is beyond C. When it is beyond C, what happens? Now let us see here. Concave mirror we are drawing. Pole P. This is principal focus. This is center of curvature. Now you have to see this. What is the distance from C to P? If you take, we know this already. Aperture means diameter of this reflecting surface is called aperture, right? We are considering the mirrors of small aperture in this lesson because the mirrors, these spherical mirrors of small aperture, in that one special case is there. What is that? The focal length, this distance F to P, this focal length, it will be half of the radius of curvature. Means what? Center of curvature to pole P. This is what? Radius of curvature, isn't it? So this distance, this focal length will be half of the radius of curvature. Because of that, we are taking these spherical mirrors of small aperture. Okay. Now, when the object is beyond C, what happens then? See, when the object is beyond C, now we are considering one ray which is passing through the center of curvature. One is parallel to the principal axis. Now the light rays which are passing through this principal axis, they return in the same path because it is normal to this reflecting surface, so they follow the same path. Now this ray after reflection, if it is parallel, we have studied in the rules. First rule we have studied, a ray which is parallel to the principal axis passes through the focus after reflection, that we already studied, right? So it must pass through the focus. Now this ray which is passing through this, what center of curvature, it follows the same path. This also we have studied in the third case, means it follows the same path after reflection. Okay. Now the point where these two rays, means after reflection, where they are intersecting each other, at this point we get the image. The image is, if it is real one, it is inverted. Okay. Now this is denoted as AB, and here it is denoted as A dash B dash, image A dash B dash we are taking, and this mirror we can denote it as MN. Okay, you can denote. Now here where it is incident, at that also we can give any point letters we can give to denote this point. Okay. So what is the nature of the image now? Okay, when the object is beyond C, the nature of the image. Now you see image is looking smaller as compared to this, right? And it is real. Next it is inverted. So first one, image is real and inverted. Real and inverted, we can say. Second point, the image is diminished, not highly diminished, it is just diminished, means smaller in size. So first one, second one, image is diminished. We will write here diminished. And third one, what is the, where is that position of the image? It is between C and F. You can see it is between C and F. Image is between C and F. C and F, we can say. Okay. This is second case, when the object is beyond C. In the beginning it was at C. In the beginning it was at infinity. Now it is beyond C. Next we have to come to at the C. When the object is at the C, what will be the nature of image formed by it? Now, when the object is at C, okay, what will be the nature of the image? Now, let us take the concave mirror. Now this is pole P. Now this is F. This is center of curvature C. Now object is at C. Say let us take it as A, B. Now we have to consider a ray. One is parallel to the principal axis. One more is passing through the focus. Okay, principal focus. Now this after reflection, this passes through the principal focus, and this after reflection, if it is already passing through principal focus, we know that already it emerges parallel, right? If it emerges parallel, you can see here after reflection we have to show the direction of incident ray and reflected ray. So now here the point where these two rays meet, it has to be accurate. The point where these two rays intersect or meet, that is the position of the image, where we find here. Now you see here we can find the image. If this is AB and A dash B dash, means what? The image is formed at C. When the object is at C, image is also at C. Now what we can say here, after reflection, means when you say the properties of the image, means nature is what? It is real and inverted. Image is real and inverted. Image is real and inverted. Next coming to size. Size is same size. Here and here will be of same size. size is same. Size of the image, size of the image is same as that of the object. Okay, this is one more. Next point is what is the position? Where is that? Image is formed at C. Image is formed at C. Formed at C means what? If the object is at C, image is also at C. It is real and inverted, and the size is same. Both object and image both are same size. So this is at C when the object is at C. Now let us come to know when the object is between C and F, what will be the nature, position and size of the image. Now, when the object is, let us take here, this is concave mirror, this is pole P, this is the principal focus, and this is center of curvature. Now, when the object is between C and F, you have to show one ray passing through, passing parallel to the principal focus, principal axis. It is parallel. After reflection, it passes through the focus. Okay. Now, it passes through the focus. One more ray you should take. It is already passing through the focus now. When it is already passing through the focus, after reflection, it emerges parallel to the principal axis. Okay, you see. Okay, now if it is passing through principal focus, it emerges parallelly, as we have studied the rules. Next, which is parallel, already parallel, it emerges, so it passes through the focus there, principal focus. Now you can see where these two rays, reflected rays, where they meet each other, at this position we find what? The image. Now you can see point C is here. Okay, point C is here. Image is what? It is beyond C. Image we are getting beyond C. Object is between C and F. This is C, this is F. Okay, object is in between these. Okay, this is A, this is B, this is A dash, this is B dash. Now you see. Now you can say here when the object is between C and F, the image is formed beyond C. Means here we are getting image. So what we can say here? The image is real and inverted, as we already studied. Same we are getting here also. Image is real and inverted. Real and inverted. Inverted. Next, coming to second point. What is the size? Size is enlarged. Size is enlarged. Enlarged size we have got, right? Because it is bigger, it is appearing bigger than the object. Okay. Next, coming to position. Position is what? Where it is formed? The image is formed. Image is formed beyond C. Beyond C. Just remember, when the object is between C and F, the image is formed beyond C. Okay. Next, this is next case when the object is between C and F. Now let us bring the same object at F.